Welcome back to our video series, when we unravel the most commonly misunderstood but exciting and crucial topics in the world of molecular biology. As a starting scientist, you might have heard people mention qPCR, real-time PCR, RT-PCR, and wondered if they're all the same thing, or is there a difference? Turns out the answer can be yes and no. Depending on the context, RT-PCR can mean qPCR or reverse transcription PCR. So when reading a scientific paper or writing one, it's important to make sure everybody understands the abbreviations correctly. When real-time polymerase chain reaction came out during the 90s, the words kinetic PCR analysis or real-time PCR were most commonly used. Also, real-time quantitative RT-PCR was used to indicate RT-qPCR. When real-time PCR became more common in the 2000s, it was more often shortened to RT-PCR or qPCR because of its main function to quantify genomic fragments in real time. It certainly makes sense to abbreviate real-time PCR into RT-PCR, and all would be well if there already hadn't been reverse transcription of PCR. Yet it was, and we are all thankful for it, except a little confused about the terminology. So, when you're reading about RT-PCR, how do you know you're reading about the right PCR? Well, you have to pay attention to the details. Also note that after the devising of MIQE guidelines in 2009, there have been fewer mix-ups between the methods. qPCR is a quantitative method used to detect, quantify, and characterize genomic fragments in real time. Reverse transcription PCR, which will be called RT-PCR, is a method that combines reverse transcription with PCR to detect RNA transcripts. Therefore, while the abbreviations may be the same, the methods are quite different. Then there is also a third option called RT-qPCR that combines both methods and is used to quantify gene expression. Now that you have gotten this far, you might be a little confused about the one-step and two-step reaction. RT-PCR and RT-qPCR obviously have two parts, so how can those be done in a single reaction? Or why is there even a need for two options? With a two-step reaction, first you perform the reverse transcription reaction in one tube and then the PCR reaction in another tube. Basically, the two steps can be considered different experiments. You can synthesize cDNA one day and then perform PCR with it the next day, or next week, or whenever you want. That way you can stock cDNA and use it for more than one experiment. A two-step approach is also good when there is a limited amount of starting material, when you want to optimize these steps separately, or when you want to detect multiple targets from the same sample. With a one-step reaction, the whole experiment will be done in a single tube, where reverse transcription and PCR components are all mixed together, which is obviously much easier and faster than doing the steps separately. There's also a much smaller possibility of contamination, and with excellent products from Solis Biodyne, you can also use one-step RT-qPCR to detect multiple targets from the same sample. All that is left now is to check out our product list and choose the product most compatible with your needs. See you soon!